There's quite a bit of science that goes into firefighting, into shooting water out of a hose. At first glance, a little bit of science, stuff we could have talked about like in grade 11 physics. We've got a Newton's third law thing. The water's being forced out of the hose in, say, a forward direction. That means equal and opposite reaction. The hose will be forced backwards. That's going on. So you've probably seen maybe fails where someone tries to hold a hose and ends up spraying water all over the place. Also, another little bit that I read about, they really do a lot of math on the nozzle speed spray and how much water is leaving it. They've done cool experiments to figure out the most effective droplet size to put out fires. It kind of depends on the type of fire, but there's math behind it about how big of a droplet of water they want the water to have by the time it gets to a fire. So they have to kind of monitor how far the water is being shot to pick the right nozzle speed so that the water stream decays or disintegrates into these droplets of the appropriate size by the time the water gets to the fire. We're not ready for that physics. By using this impulse concept, we can figure out the force that the firefighters would have to overcome if they're holding onto this hose shooting out the water. Impulse has got two equations, F times T. And what I like about this one is I've been a little bit lazy in the last couple questions. I kept saying impulse is delta momentum. If you look back in our Google Doc, we have to go to a version a little bit before our delta momentum. We have to go to this version. I can't write it as delta P. I'm going to write it as delta MV. Hopefully you'll see why in a sec. In this case, the mass is changing over time. We've got this number in kilograms per second. So my delta MV is going to stay. I'm going to divide by delta T. Really what I've got, the 2 number, is the delta M over T. It's telling us the rate at which the mass is leaving the hose, but it's leaving at a constant speed of 30. So instead of doing a change in momentum, I'm going to break impulse down a little bit differently. I'm going to say the average force is delta M over T, and the V is constant, so I can kind of factor it out of the delta MV, and it's just going to be on its own, delta V. For a question like this one, the delta M over delta T was given, that was the number 2. The speed was given, that was the number 30. Multiplying those together, 2 times 30 is 60. By the coolness of the metric system, that works out to be newtons. So I like this one because instead of thinking of it in terms of momentum, and momentum is usually mass, the change in momentum would usually be mass times change in velocity. Our change in momentum this time is different. It's going to be velocity multiplied by change in mass.